Good afternoon, my YouTube viewers. In this particular video, what we're going to be doing is we're going to be doing confidence intervals of adult male heights. And so the question is, you are conducting a survey to estimate the average height of adult males in a city. You collect a random sample of 100 heights with a mean of 175 centimeters and a standard deviation of 15 centimeters. You calculate 99% confidence interval for the population mean height. Since the population standard deviation is unknown, the t-distribution will be used. So they gave you a hint. So that's good. You don't have to try to figure it out on your own. So the sample mean is 175. Sample standard deviation is 15. Sample size is 100. Confidence level is 99%. Degree of freedom is 99, because your degree of freedom is your sample size, that's B8 minus 1. Standard error is B7, that's sample standard deviation, divided by the square root of B8. So that's going to be 15 divided by 10, so that's 1.5. Critical t-value is t.inv.2t, so t means it's a t-distribution, and 2t means it's two-tailed. Brackets 1 minus B9, that's 1 minus 0.99, comma, B10 is your degree of freedom. So you got a 2.626. Your margin of error is B12 times B11. So your margin of error is 2.626 times 1.5. So that's 3.93. So your lower bound is confidence interval. Lower bound is 1.71, and confidence interval upper bound is 1.78. I'm just trying to find this out. So margin of error. So the lower bound is 1.71, and the upper bound is 1.78. So that's margin of error is B6 plus B13 for your upper bound. So that sample mean 175 plus B13, which is your margin of error. So this one should be equals B6 minus, so that's 1.71. And then what we've done is I've created a normal distribution, because as I said in the last video, it's not really feasible to create a t-distribution for this. So we have to do it based on a normal distribution. But we have values of 120 all the way up to 220. So we've got 100 rows of data where we have values. And then your t-distribution PDF is actually, it's a normal distribution, because it's not really feasible to do this with a t-distribution. So normal distribution equals norm.dist brackets D7, comma, B7, that's your standard deviation, comma, false. That means it's probability distribution function, or PDF. And then what we've done is we've actually created a chart, a graph for this. So we created a normal distribution, and we put the lower bound confidence interval and the upper bound confidence interval on the graph, so you can see where the lower bound and the upper bound fit in that area. And if you come over here, and I did actually make the graph, so if you come over here, it's actually 3 charts that are superimposed on each other. So the one chart is the T-District PDF, which is really a normal district PDF. And then you've got your lower bound, and then you've got your upper bound. And that demonstrates or illustrates where your confidence interval is. And so what I'll do is, just to make this more accurate, well, I'll leave it as a T, but really it's not feasible to do it as a T distribution. You have to do it as a normal distribution. So you can see that your lower bound confidence interval is 171.0604, and your upper bound is 178.9396. And so 99% of all the values are going to be between the lower bound and the upper bound. So that concludes this video. The next video is going to be about a grocery store. So I hope that you decide to watch it.